Okay, now we'll continue with the next half of this lesson. And what we had ended the last one by saying was that with impulse, by increasing the time of impact, the force of the impact can be increased. So if you increase the time of the impact, you decrease the force that's exerted on the object. So here are some practical applications. Modern cars are safer than older cars. An older car was built with a very stiff frame. A lot of steel, iron. These cars would not bend or crumple. You get very little damage. I know here it might look like a lot, but in terms of the structure of the car, you don't get a lot of damage done. The problem being here is that it took much less damage than a newer car, and during an accident it was stopped very quickly and the force was transferred to the driver. So the car comes to a stop very quickly. All the force of the impact is driven back to the driver. Versus if you look at a newer car, accidents can look more severe. Really they're not. What happens with newer cars is that they have crumple zones built into them. So if you were to think about the front of the car being here, that the frame in the front of the car will be designed to bend at particular places, so that all the energy impact, so if you had a tree here, the energy of the car hitting that tree went into crumpling the car and not into driving all the energy back into the driver. So it would lengthen the time of the impact, therefore reducing the force that the driver felt. You guys feel the same thing sometimes, maybe in gym class. If you had a volleyball and you had one of those foam Nerf balls. If you're playing dodgeball, which one's going to deliver more impact to you? If you're playing with a volleyball, you can deliver more impact to someone because the ball is rigid, it's hard, it's in contact with a person for a much shorter amount of time and can deliver more force. Whereas if you think about the Nerf ball, you can take the shape of the person. It takes more time for that ball to stop, therefore delivers less force. Many applications in sports. Think boxing gloves. That's why boxers wear the gloves. Takes much longer for the glove to come to a stop than it would a bare fist, delivering less impact to the opponent, and also making it easier on each person's hands. Okay, second application. Rubber buoys are placed between a boat and the wharf as it docks. The impulse or change of momentum at impact will be the same with or without the buoys. By placing the buoys, we increase the time for the boat to stop. This means that the impact force is lessened. So with the buoys there, they'll take the energy of the impact with the wharf. So as the boat will come in, it takes more time for the boat to come in contact with the wharf because the buoy itself has to be compressed. And remember, I mentioned impulse, mass times change in velocity. So the impulse doesn't change. Momentum doesn't change there. What we're changing is how long the object is in contact. So impulse is your force net times time. So the more we can lengthen that out, the less impact can be felt. What I want you to do now, you can pause the video and answer each of the following journal questions, and you can answer these on the sheet provided. So you should have this sheet here given to you. So why should you bend your knees as you jump from the stage in a gymnasium and land on the floor? Why do stuntmen use giant airbags when they land high-fall stunts? Not students, stunts. Automobile passenger airbags increase safety during accidents. Why? And which will be better for driving a nail in a board, a steel hammer or a rubber mallet? Explain terms of impulse momentum. And when you finish that, we'll continue with the next couple questions. Okay, assuming you have that done now. The impulse of a collision is equal to the object's change in momentum. So since the mass of the object nearly always remains the same as it stops, only its velocity changes. So as a car comes to a stop, usually its mass would remain the same, or if you're thinking about jumping a trampoline, as you're jumping up and down, your mass is remaining the same. The only change is your velocity. This leads to the following formula. So the impulse momentum theorem. Theorem is sort of like a fact or a law. So we have impulse momentum equals change of momentum. So here, this is the impulse part. We have force times change in time. That's impulse. The units are newtons times seconds, force times time. And remember what a newton is. A newton is 1 kilogram times meter per second squared. Time, the unit is still second, and we will get a canceling here. Seconds can cancel with one of the seconds here. So the unit that we have is kilograms times meters per second. Over here on this side, this part here is the change in momentum, and the units are the same. Kilograms times change in momentum. So the units are the same for those used in momentum. Now we'll apply that formula. The net force of 4.5 newtons is applied to a stationary dynamic cart with a mass of 1.15 kilograms. What will be the velocity of the cart after 2.5 seconds? And you apply in what you know. You know you have a force of 4.5 newtons. Time is 2.5 seconds. Mass of the object is 1.15 kilograms. And your change in velocity, well, it was a stationary cart. So that means that V1 was 0. And we need to find V2. And change in velocity is always V2 subtract V1. So V2 subtract 0. Multiply here, and you get 11.25. V2 subtract 0 is just V2 times 1.15. And to solve for V2, divide both sides by 1.15. And you have 9.8 meters per second squared. Now the next 3 questions look for you to do on your own. The answers will be shown after and posted on the course site. So you can read through each of these yourself. They will be posted here. I assume your teacher will pause the video for you. And as well, you can look on the course site. And after you've tried them yourself, you can go through and see any of the answers there. And if you have any questions on how these are done or anything you need cleared up, I'll take your questions when I get back. Or you can send me a quick email and I'll take them that way.